Hello guys, good morning. Good morning to all of you. Can you hear me properly? Yes, let me know. Once we are all clear, then we'll start. Today we'll be discussing the third part of the linear harmonic. Once we are all clear. Okay, so today we'll be discussing the third part of the linear harmonic oscillator. And we'll try to finish this harmonic oscillator by today. Okay, this may be a little bit longer classes. I don't have invigilators on duty, so we can take it for a long time. So let us start with 2D and 3D harmonic oscillator. I have already talked about it. We have only talked about the energy eigenvalues. Now we'll also talk about the eigenstates. So let's briefly talk about 2D harmonic oscillator. 2D harmonic oscillator. So in general, what we need to know. Harry, welcome Harry. What we need to know, you see here the potential harmonic oscillator, 2D harmonic oscillator potential is expressed in this way, half m, look, omega x square plus half m omega y square. This is the most generalized one. Now we are just considering that omega x is equals to omega y. If omega x and omega y are not equal, then you know what you have to do. If omega x is equals to omega y is equals to omega, v of xy is equals to half m omega square x square plus half m omega square y square. Okay, so for this kind of potential, we know the energy eigenvalue E nx ny will be the sum of corresponding energy for x, corresponding energy in y. So for x we will get nx plus half h cut omega. If it is omega x, then we could have got h cut omega x, okay, plus ny plus half h cut omega y or h cut omega. Then we wrote it in this way, nx plus ny plus 1 h cut omega, where your nx ny both goes from 0 1 to 3 and so on. So you get ultimately nx plus ny is equals to n, so n plus 1 h cut omega, where this n is nothing but the sum of nx and ny, and it can also take values like 0 1 2 3 and so on. Okay, now before going further into it, okay, just add a line here if you have space. The wave function will be multiplicative in nature. So if I am talking about, let's say, psi nx ny, so function of x and y, this will be the product of, let's say, the wave function for x and the wave function for y. So it will be multiplication or product of the wave function in x and in y. Now let us try to understand a degeneracy. If this is the energy of the two-dimensional harmonic oscillator, energy of the two-dimensional harmonic oscillator is given by n plus 1 h cut omega. So for this, what is the ground state? If I am talking about ground state energy, what will be its value? For ground state, we have to take Nx is equals to 0. Acha, we can make it like we should write it in this way. Just a moment. Nx plus ny plus 1 h cut omega is equals to n plus 1 h cut omega. So if Nx is equals to 0, ny equals to 0, this gives you ground state. Let's say I'm writing E0 is equals to E00. This is equals to how much? H cut omega. Okay. No issue. I am talking about first excited state. First excited state. Where is Murli today? Murli is not up. First excited state. To get first excited state, you see, we can take Nx is equals to 1, Ny equals to 0. We have to like find the next minimum. Minimum is h cut omega. We have to find out the next minimum. So if you take Nx is equals to 1, Ny equals to 0, you get how much? You get E. Okay, let's denote it by E. E is equals to 1 plus 1 to 2h cut omega. Or you take Nx is equals to 0 and Ny equals to 1. For both these cases, you get E is equals to 2h cut omega. What does it mean? It means this is degenerate. First excited state is degenerate, and it has the degeneracy. Let's say denoting by G. It is 2. Here degeneracy is 1. G is degeneracy. Okay. Now, if I talk about second excited state, so how we can get second excited state? The next energy maybe 3h cut omega. So next excited state you can get second excited state you can get Nx equals to 2 if you put, and Ny is equals to 0. Then you get E is equals to 3h cut omega. Okay. Good morning, Murli. If you take Nx is equals to 0, Ny is equals to 2, then again you get E equals to 3h cut omega. Check whether you are getting it or not. Now, furthermore, if you take Nx is equals to 1, Ny is equals to 1, then also you get E equals to 3h cut omega. Means this state is also degenerate with degeneracy 3. So h cut omega, 2h cut omega, 3h cut omega. Next you can go for 4h cut omega. But you see a pattern. If you go to nth excited state, so for a lot of choices of Nx and Ny will produce the energy E is equals to N plus 1 h cut omega. Okay. With degeneracy G is equals to, you see how much? N plus 1. Here you can see ground state G equals to 1. First excited state G equals to 2. Second excited state G equals to 3. So you see 1 unit is more. So for nth excited state, you can expect that the degeneracy will be N plus 1. So you can write the degeneracy. So this is the ultimate conclusion, that the degeneracy of the 2D harmonic oscillator for nth state is n plus 1. So I hope 2D is clear. Let's move on to 3A harmonic oscillator. Harmonic oscillator. So for 3D, you can express the potential in this way: V of x by z. If you write the most generalized one, half m omega square, omega x square plus half m omega y square plus half m omega z square. This is the most general one. Now if omega x, omega y, omega z becomes equal, let's say omega, then it is called, then the oscillator is called isotropic oscillator. Isotropic. Okay. So for isotropic case, your V of x y g becomes half m omega square x square plus half m omega square. So we are not taking common, just to show you that it is separate. Okay, you can always take common, but just to stress that all the each dimensions are independent. When you find the eigenfunction, the dimensional part will get multiplied, and when you find the eigenvalues, the dimensional part will play a role by making addition of the energy eigenvalues corresponding to each dimension. Okay, that is why intentionally we are keeping the terms separated. Okay, so what is the wave function? Psi nx ny nz. It is in 3 dimensions, so you can write it as a function of x, y, z. So you have to product the corresponding part of the wave function for the x axis, y axis, z axis. Okay, as simple as that. So main important thing is here is the energy eigenvalue. So what will be the energy eigenvalue? E is equals to nx plus half, you can write h cut omega x plus ny plus half h cut omega y plus nz plus half h cut omega z. Now if here you can see as usual your nx, ny or nz, they all will start from 0, 1, 2, 3 and so on. So isotropic, for isotropic case, for isotropic isotropic harmonic oscillator. As I have already told you, we have to equate omega x, omega y and omega z. Okay, equals to omega. So your energy eigenvalue, let's write it as E n x n y n z. It doesn't matter how you represent nx plus ny plus nz plus 3/2 and h cut omega. So you can combine and write it as n plus 3/2 h cut. Okay. Now n will start from 0, 1, 2, 3 and so on. Now we'll try to look for some of the states. Here, what will be the ground state? Is the ground state non-degenerate or degenerate? What do you think? For ground state, obviously you have to choose nx is equals to 0, ny is equals to 0 and also nz equals to 0. So if you choose that, you get the energy 3/2 h cut. So here main deciding factor is, if I am writing here, let's say nx plus ny plus nz. So n is equals to nx plus ny plus nz. This value is 0. So next we have to find out such a value that it will be 1. So how 1 is possible? How 1 is possible? As you can see, this will give you first excited state. So this is how you check nx is equals to 0. Sorry, nx is equals to, you can take 1, ny equals to 0, nz is equals to 0, then it is 1, nx is equals to 0, ny equals to 1, nz equals to 0, nx is equals to 0, ny is equals to 0, nz equals to 1. Okay, so for all these cases, this is 1. And the corresponding energy, as you can see, how much? 1 plus 3/2, that is 5/2 h cut omega. Let's do another one, second excited state. So obviously the next big number is 2. In how many ways you can make 2? In how many ways? You see, you can take nx is equals to 1 or 2, n is equals to 0, nz is equals to 0. Okay, nx is equals to 0, ny is equals to 2, nz is equals to 0, nx is equals to 0, ny is equals to 0, nz is equals to 2. So this is how you make 2, or you can also choose nx is equals to 1, ny is equals to 1, nz is equals to 0. Then you see, you can check, I don't have space here. You can take nx is equals to 0, ny equals to 1, nz equals to 1. Further, nx equals to 1, nz equals to 1, and ny equals to 0. So few more you will get. So what will be the degeneracy here? The degeneracy, we did not make a column, right? So here degeneracy, g value is 1 here. Here it is 3. Here it is how much? 6 probabilities, 6 possibilities. Okay, so you are saying it is 6. So the energy will become for this 7 by 2 h. If I go to third excited state, can you tell me what is the G value? Tell me, for third excited state, how many values you are getting? Just tell me the answer. $12. So to tackle this, if you are considering a harmonic oscillator, you can write it just under it. I don't have a space, so that is why I am writing it here. So we can get a generalized formula. The degeneracy of, and this is valid for isotropic case only. Okay, if omega x, omega y and omega z are different, then you have to check manually, okay, by taking energy values. So the set of quantum numbers will get changed if omega x, omega y and omega z are different. This formula is applicable only when isotropic case. Isotropic harmonic oscillator. The degeneracy G of an isotropic harmonic oscillator, that is where omega x, omega y, omega z are equal. The degeneracy G of an isotropic harmonic oscillator for the nth state is given by Gn is equals to half times n plus 1 times n plus 2. And as you can see, for if you put n equals to 0, you see it is 1. If you put n is equals to 1, 1 plus 1, 2, 2 to get cancelled, 1 plus 2, 3. Okay. If you put n equals to here ground state, it is n equals to 0, first excited state n equals to 1, second excited state n equals to 2, third excited state n is equals to 3. So if you put n equals to 3, so 3 plus 1, 4, so 2 and 3 plus 5, 3 plus 2, 10. 10 will come now. How it is true? Ten will come. Third. Yes. Is it clear? Remember, sometimes you people get confused. What value of n should be taken? You don't consider it like particle in a box. Here n is equals to 0 corresponds to ground state. Remember this one corresponds to ground state. So it may possible that in the examination it is asking what is the degeneracy for the second excited state. So you get too excited that if you put n is equals to for second excited state, if you put n is equals to 3, then it will be wrong, because for particle in a box ground state corresponds to n equals to 1, first excited state corresponding to n is equals to 2, second excited state n equals to 3. So if you set up calculation in that way, then it will be wrong. You have to consider n equals to 0 ground state, n equals to 1 first excited state, n is equals to 2 second excited. So it is a normal case. Okay, second excited state n equals to 2. Okay. Yeah, I took n value wrong. Yeah, this is the problem. That's why I am telling it. This is the problem. People take the value of n wrong here because they just intermingle with that particle in a box problem. Okay, so while choosing the value of n, be very careful. If you are dealing a particle in a box, then n starts from 0. This is the only case where n starts from 0. In other cases, n starts from 1. As this is enough for this 3-dimensional case, let's look at some problem. This came in December 2011. The energy of the first excited quantum state of particle in the 2D box. Tell me, I think you can tell me in 30 seconds. Tell me the answer quickly. Could you solve this problem? Hurry up, guys. What is given to us? Option A you are getting. Look, V of xy is equals to half m omega square x square plus half m omega square 4y square. Can I write it in this way? Now the format is half m omega x square plus half m omega y square. So 4 omega square we have to take. So that is 2 omega square y square. Right? So what is omega x? Omega x is equals to omega y is equals to 2 omega. Now energy, what will be the energy expression? You see it is nx plus half h cut omega x plus ny plus half h cut omega. You see this is not, here the omega values are not same. Along omega x and omega they are different. So you have to use this formula. Okay. So this is nx plus half h cut omega plus ny plus half 2h cut omega, because omega y is equals to 2 omega. Now the energy for the first excited quantum state. First excited quantum state. So you see, if I write it nx plus half and here 2ny, so nx plus 2ny half plus 1 is 3 by 2. Then we can take h cut omega. Okay, I think up to this it is clear. Now if I talk about the ground state will be for nx is equals to 0, ny equals to 0. This is for ground state. If I am talking about ground state corresponding to nx is equals to 0, ny is equals to 0. So E becomes, you see, 3 by 2 h bar omega. Now if I talk about first excited state corresponds to nx should be taken 1, ny should be taken 0. If you take ny is equals to 1, nx equals to 0, that will not be first excited state, that energy will increase. If you check nx is equals to 1, you have to find out the next minimum. Minimum is 3 by 2 h cut omega. First excited will be the next minimum with whatever possible allowed values of nx and ny you take. Okay. So here what is the energy? 1 plus 3 by 2, so 5 by 2 h cut omega. So it is 5 by 2 h cut omega. Is it clear? You have to look for the option. You have to check the question properly. Otherwise, you will make mistake. Is it clear, Harry? A would have been the answer if maybe both were isotropic. Both this omega x and omega y were equal. Then we could have told that it is 2 h cut omega. But it is not. Is it clear now? Let's do another problem. If the potential of three-dimensional harmonic oscillator is given by this, and you see the omega values, omega 1 is equals to omega, omega 2 is equals to 2 omega, omega 3 is equals to 3 omega. Given below are two statements, study them and choose the correct option. First statement, correct. Second excited state has energy 5 h cut omega. And it is doubly degenerate. Which of these statements are correct? Is or are correct? So once again we'll write the expression of energy E, nx, ny, nz. So this is, let's say, nx plus half h cut omega x plus ny plus half h cut omega y, nz plus half h cut omega z. Can I write it? So omega x is equals to omega, and that is why it is nx plus half h cut omega, ny plus half h cut 2 omega. So 2 h cut omega. Here nz plus half 3 h cut omega. So if I write it in a more compact form, nx, okay, plus 2 ny plus 3 nz plus half plus 1, 3 by 2, 3 by 2 plus 3 by 2, so 3, okay, 3, we can take now h cut omega. In this question, system is not mentioned. How to find which system they are asking? Can we find using given potential? System is not mentioned. It is three-dimensional harmonic oscillator. Which system? Well, I'm not getting your question. What do you mean by system here? Everything is given, na? Now, here, how can you get ground state? So, for ground state, what you can use? For ground state, obviously, you will choose Nx is equals to 0, Ny is equals to 0, Nz is equals to 0, and that gives you E 0 0 is equals to 3h cutoff. Let's say if you consider first excited state. First excited state, how will you get? Look, you have to choose minimum for the quantum number with higher indices, right? If this is 3, Nz, you will increase the value of Nz from 0 later. First you have to increase, to keep it minimum, you have to increase Nx, right? So you have to check Nx is equals to 1, Ny is equals to 0, Nz is equals to 0. So in that case, your energy will become 4h cut omega. You know, it will be in integer. So obviously we expect 4h cut omega after 3h cut omega. Okay, 1 0 0. But if you think 0 1 0 will be first excited state, then you are wrong. 0 1 0, that will not be first excited state, that will be second excited state, because the energy is getting changed and it is getting higher. So it will go to second excited state. For second excited state, you can choose Nx is equals to 0, Ny is equals to 1, Nz is equals to 0. What if you choose Nz equals to 1, then it will not be in second excited state, it will go to some other excited state. Okay. For this, E will be how much? 2 plus 3 5, 5h cut omega. 0 1 0. And another choice can give you this. If you choose Nx is equals to 2, Ny is equals to 0, Nz is equals to 0, then also you get E equals to 5 by 5h cut omega, right? Then also you get 5h cut omega. Is there any other choice that can give you E equals to 5h cut omega? The answer is no. No, it means it is doubly degenerate. It is doubly degenerate. Now check the options. It says second excited state has energy 5h cut omega, that is true, and it is doubly degenerate is also true. So both option 1 and 2 are correct. Option C is the correct option. Murli, tell me, what are you asking? Okay, let us do another problem. Little bit difficult problem though. This came in December 2012. Difficult, but if you go in a systematic way, it may appear to be easy. So if you add some modification like half m omega square x square, you know that energy is equals to n plus half h cut omega. So how if you add minus x to this potential, how the energy eigenvalue will be changing? That is what it is asking. Previous question, system is not mentioned. What do you mean by system? The system is mentioned now. The harmonic oscillator system, three-dimensional harmonic oscillator system. What else you want to know about? You can ask me in personal DM if you are not able to put it out. Okay, let's focus on this problem. Yeah, previous question means talking about this. Here, energy of the first excited quantum star particle in a 2D box, 2D potential is. So what needs to be mentioned here? Okay, you can inform me. Let's focus on this problem now. Yeah, from the potential expression we have to understand it is a harmonic oscillator. Yes, it may not be exclusively mentioned, but here it is mentioned, a harmonic oscillator. In this two-dimensional potential, it is not explicitly mentioning harmonic oscillator, but from this form half m omega square x square, half m omega square 4 square, you have to understand it is talking about two-dimensional harmonic oscillator. Okay, let's talk about this problem. Isotropic or not? So if omega values are equal, then it is isotropic. If omega values are not equal, then you have to consider it to be anisotropic. We have to put it into the general form, that is half m omega square x square. X square should be free. Half m omega square y square. You see, if it is y square, so whatever term is there, it will be incorporated in here, no, in omega y square, because y square is y square, there will be no changing. X square is x, there will be no changing. You have whatever modification you need to do it here in omega x and omega y. No, y, x and y are variable, no? So that is why 4y square is there, but we took this 4 inside this. Let's look at this problem. So the potential is given by this. Okay, now let's talk about the conventional one. If let's say you have a conventional v of x is equals to half m omega square x square, then Schrodinger equation, if you use Schrodinger equation, gives, you see, minus h cut square by 2m d square psi by dx square plus half m omega square x square psi is equals to E psi, and we write d square psi by dx square plus twice m by h cut square. See, it is E minus half m omega square x square into psi is equals to 0. Okay, so for this case you write the energy eigen value is E is equals to En is equals to, let's say we write it n plus half h cut omega. Now in the question, V of x is changed. Okay, V of x now become half m omega square x square minus x. So the modified Schrodinger equation will be what will it become? You see, this will become d square psi by dx square plus twice m by h cut square E minus, you see, half m omega square x square is there. So half m omega square x square is replaced by half m omega square x square minus x, but here already a minus sign is there, so minus minus plus. Okay, so for this you will get En prime, which will be different from this. Okay, so let's name this equation. This is 1. Now let's simplify this. So what I am writing, let's say d square psi by dx square plus twice m by h cut square. I am writing, let's say E. We have to make this expression as similar as equation 1 as possible. Okay, then we will just write the energy eigenvalue, then we will compare and we can get the answer. E, you see, minus half m omega square x square plus x, so we can put it in the form of a square plus 2ab plus b square in this form, or a square minus 2ab plus b square in this form. To put it into that form, let's say I am keeping it here, we will write another term here later. For the time being, you can see minus half m omega square. We are taking this half m omega square common, so x square will come. Now we need to make minus x, right? Plus x is there, so minus we have taken common, so we have to make it minus x. So minus, how this will turn into x? So m omega square is extra, so we need to just cancel this m omega square, so we can divide by m omega square. Okay, divided by 2, so we have to multiply by 2, and x was there, so x. Now you calculate minus minus plus, 2 get cancelled, m omega square cancel, so ax remains. So we have just written whatever is given in the previous step. Now we want to make it a perfect square, so x square minus 2ab, so 2 into x into a by m omega square. So a by m omega square is treated like b, so here what you write, a by m omega square square, so a square by m square omega to the power 4. Okay, can I write it? Now the problem is this term was not there, we have taken extra, so you see minus half m omega square into a square by m square omega to the power 4, this is extra, so we have, it is in minus, so we have to add another term here, that is a square divided by, if you see, 1m is cancelled, omega square is cancelled, so a square by 2m omega square, right? 2m omega square. So now it is balanced, multiply by this psi equals to 0. Is this line clear, guys? Tell me. It's a very crucial line. If it is clear, then the upcoming things will be pretty much easy. This is equals to d square psi by dx square plus twice m by h cut square. You see, E plus a square by twice m omega square minus half m omega square, and what is this value? x minus a by m omega square times psi. Now let us take E plus a square by twice m omega square is equals to E prime, and x minus a by m omega square is equals to x prime. So if this is so, if you take derivative on both sides, so it becomes dx prime is equals to dx, because this thing is changed. So your psi of x will become psi of x prime, because you have changed the variable. So this equation, let's say let's name this equation. This is 1, this is 2, let's say. So what we can write, therefore equation 2 becomes dx prime is equals to dx. So obviously dx prime square will be dx square. So we can write d square psi of x prime, let's say, divided by dx prime square plus, we are just changing the variable, twice m by h cut square. This becomes E prime minus half m omega square x prime square times psi is equals to 0. Let's name it equation 3. Now if you look at equation 1 and equation 3, you can find out a similarity. Okay, it is just replaced by prime, so the energy eigenvalues will be same, because if you just replace it with prime, then the energy eigenvalue is bound to change, right? Here it is psi of x prime. Sorry, what did I say? What did I say? The energy eigenvalue. What is happening? Look, if the equation is not changing, the energy eigenvalue format will not changing. So comparing equation 1 and 3, what do you get? Comparing equations 1 and 3, we get, what do you get? Let's say we are writing the energy En prime. This will be n plus half h cut omega. Okay, because the format is same, you have just changed the variable. So energy eigenvalue, the right hand side will remain same, n plus half h cut omega. Now what is En prime? Or better you write, if I write it here it is E, and En where it is E actually. Here you can write En if you want to write En here. So it is E prime. Okay, so this E prime is this E prime. Now E prime is E plus a square by twice m omega square. This is equals to n plus half h cut omega. So that is why E is equals to n plus half h cut omega minus a square by twice m omega square. This is matching with option A. Is it clear, guys? Very standard question, but easy. You just need to understand few steps. Any question from this question? Hari, Karthik, Murli, is it clear? Can we move to the next problem? It came in June 2013. Let's do it. Consider the normalized state psi of a particle in a one-dimensional harmonic oscillator. Psi is equals to B10 ket plus B2 ket 1, where 0 and 1 denote the ground and first excited states respectively, and B1 and B2 are real constants. Expectation value of the displacement x in the state psi will be a minimum when. So you are given a one-dimensional harmonic oscillator and a normalized state is given, that is psi B1 0 plus B2 1. 0 is the ground state and ket 1, this corresponds to the first excited state. So this is given to you. So if this is psi, what will be this is ket psi, so what will be bra psi? So obviously it will be B1 and B2 are real constants, so you should not write, you can write B1 star is equals to B1 bra 0 plus B2 bra 1. Okay, now you have to find out the expectation value of displacement x in the state psi. So the expectation value is given by expectation value of x. Psi is normalized, it is asked normalize, right? Normalized state psi. So we can also write here, since psi is normalized, what does it mean? Psi equals to 1. If psi is equals to 1, we can write it here actually. Since psi is normalized, psi equals to 1. And that is why you can write B1 square, B2 square, sum of it is equals to 1. So what is the expectation value of x in the state psi? It is psi x psi divided by psi is 1. You can write it for the sake of completeness, psi x psi, right? What is this equal to? Look, B1 square 0 x 0 plus B2 square 1 x 1 plus B1 B2 0 x 1 plus B2 B1 1 x 0. Clear? Now you see, you know how to determine this term. If you have, let's say, for an example, if you have psi x psi. How do you write it? Minus infinity to plus infinity, you take psi star, then you put x, then you put psi, then you write dx. So this is the integrand. If this integrand is odd, then this value becomes 0, right? Now here you can see it is 0 and 0, so it may be even or odd. But x is an odd function, right? So, but here you see 0 0, that is even, so odd into even is odd, so this term will vanish, right? You see, since x is an odd function, 0 x 0 and 1 x 1 will be 0. Is it clear or not? Tell me. How can you say x is what? X is what, na? F of x is equals to x. F of minus x is equals to minus x minus f of x. So that is why x is what? Even plus odd, na? Even into odd. Even into odd is equals to odd. Actually, even function into odd function gives you odd function. Odd function into odd function, that gives you even function. Even function into even function, that also gives you even. Okay. So here look, 0 1 1, that may be even, and x is odd. Okay. Here you see 0 and 0, that will make it even. Even both of them are odd, that odd into odd will become even, and x is odd, so that is becomes odd overall. Here also, even if it is even or odd, the product of 1 and 1, it will be even, and x is odd. So that is this. That is why these two terms bound to 0. So the expectation value of x becomes how much? b1 b2 0 x1 plus 1 x0, right? b1 b2 0 x1 plus 1 x0. So b1 b2, what is x? X is square root of h cut by twice m omega. We have already told you it is square root of h cut by twice m omega a plus a dagger. If you check the previous class, you will see this. And this is equals to square root of h cut by twice m omega b1 b2. You see 0, again you are getting 4 terms, 0 A 1, 0 A dagger 1, 1 A 0, 1 A dagger 0. So what does it give you? Square root of h cut by twice m omega b1 b2. You see a lowering operator, so that is, what does it make it? What does it make? Square root of 1. Okay, square root of 1, then 0 0, that is 1. Don't think 0 0 is equals to 0. Okay, this is state. So you will get 1 from the first term. Second term, a dagger, make it 2. So this term is 0. A 0 is 0. So this term is also 0. A dagger 0 makes it 1. So one other term will come. So this is equals to 1. This is equals to 1. So this becomes 2 times b1 b2 square root of h cut by twice m omega. Is it clear till now? Now, under what condition this x will be minimum? X will be minimum if b1 b2 is minimum. Now b1 b2, to find the minimum value of b1 b2, what you can do? b1 b2. So let us write it as 1 by 4 times 4 b1 b2. We have just written it in some other way. So it is a 4AB formula. You know the 4AB formula. If you have, let's say, what is the 4AB formula? You have read it in class 7 or 6. A plus b whole square minus a minus b whole square. This is 4AB, right? So we are writing that thing only. 1 by 4, 4AB. Here A, B are B1 and B2. So B1 plus B2 whole square minus B1 minus B2 whole square. So for what values of B1 and B2, this B1, B2 will be minimum? Look, if you choose B1 is equals to B2, then this part will be 0. Okay, so this is positive, positive minus 0. So we will have some value. But if you choose, let's say B1 is equals to 0, B2 is equals to 1. So it will give you positive minus 1. So obviously that is lesser, na? So for when B1 B2 will be minimum, so B1 B2 will be minimum if, look, we have to also keep in mind that this condition must be satisfied. B1 square plus B2 square should be 1. Cannot take any random values because this is the condition we have set. So keeping that in mind, to make it minimum, B1 B2 will be minimum if we take B2 is equals to 0 or B1 is equals to 0. Okay, so whether you take B2 is equals to 0 or B1 is equals to 0, then the criteria will be satisfied. Let's say if you take B2 is equals to 0, so B1 will be how much? 1 due to normalization. B1 square plus B2 square should be 1. So if you take B2 is equals to 0, so B1 square is equals to 1, so B1 is equals to 1. Another case, if you take B2 is equals to 1, then B1 you must choose 0 to keep this normalization condition intact. So the correct option is 0 1, B2 is equals to 0, B1 is equals to 1, option A. If you choose B1 equals to B2, then also possible, like if I am saying that okay, B1 is equals to B2 is equals to, let's say, 1 by root 2 if you take, then also this criteria is getting satisfied. 1 by 2 plus 1 by 2 is 1. But the problem is, if you take B1 is equals to B2 is equals to 1 by root 2, so this will not be minimum. Minimum value you will get by choosing 0 and 1 or 1 or 0. Understanding why this is not possible, B1, B2. Tell me, this was a good question. I think you have understood. Any question? Harry, Karthik, Murli? If not, then let's go for this problem. If the root mean squared momentum for a particle in the ground state of one-dimensional simple harmonic potential is P naught, its root mean squared momentum in the first excited state is. Root mean squared. So when you do it, you have to follow it in the reverse order. You have to first make square, then mean, then root. Root is mean squared momentum in the first excited state we have to find out. In the ground state it is P0. What about the first excited state? So if I can find out in any state, let's say root mean squared momentum of a 1D harmonic oscillator potential for generalized case, we can consider nth state. So for nth state is given by, look, squared momentum squared mean okay, this becomes mean, then squared by doing expectation value n p square n mean and then root. It is related to uncertainty. Yes, we have already done this kind of stuff before. So this is RMS momentum in the nth state. So what about the RMS momentum in the ground state? Root mean squared, let's write it RMS. Okay. So RMS momentum of the ground state. Ground state, you know, n will be replaced by 0. So 0 p square 0. What is p square? If you remember, p square is what? P square to know about p square, we need to know about p. P we have written in terms of the raising and lowering operator minus I into square root of h cut m omega m h cut omega by 2 a minus a dagger na, or if I write a dagger minus a, then this negative sign can be taken out. ये बार बार क्या आ जाता है? Okay. This was the value of p. So p square will be square of it, and you will end up getting this 0. Now p square I square is minus 1 minus m h cut omega by 2. Okay, a dagger minus a. So if I just absorb this minus, we can write a minus a dagger. Okay, minus cannot be absorbed. A minus a dagger. Either you write a dagger minus a minus a dagger. Square if you take, then it doesn't change. Can I write it? Even if you add a minus, then you have to write it a minus a dagger. Okay, the way you have remembered, you can use the formula accordingly. Okay. So this is equals to square root 0 minus h cut m omega, that is the one thing constant, so you can just take it outside of the mesh, minus m h cut omega by 2. So let's keep it only this term, a into a square minus a dagger minus a dagger a plus a dagger square 0. Can I write it? So this will become square root minus m h cut omega by 2. Now you know 0 a square 0. Okay, let's write another line, otherwise you may get confused. 0 a square 0 minus 0 a dagger 0 minus 0 a dagger a 0 plus 0 a dagger square 0. Now what are these terms? You know it very well that a operating on n produces square root of n minus 1, and a dagger raising operator produces square root of n plus 1, right? And a operating on 0 is 0, and n prime is equals to delta n prime. So these four things will be used to decide about these four terms. So using these four terms, you will see what value you will get. A square operating on 0, so this will be 0, right? You see a dagger will be operated on 0, so that makes it 1. Then a makes it 0 again, so this is minus 1. Okay, this is actually 1. This one is 0. A dagger operating on 0, so this is also 0. So this becomes minus m h cut omega by 2 times minus 1. So square root of m h cut omega by 2. And this is given to you, the expectation value or RMS value of momentum in the ground state is P0. Okay. So this is given to you as P0. So you have to find out the expectation RMS value in the first excited state. RMS momentum in the first excited state. What will you write? We wrote 0 p square 0. So here first excitation means 1 p square 1. Can I write it? So this will be again minus m h cut omega by 2 1, and again those 4 terms will come, a square plus a square minus a dagger minus a dagger a plus a dagger square. Okay, na? Now again you can use this formula, right? So it is minus m h cut omega by 2. You will get 4 terms, 1 a square 1. Okay. Minus 1 a dagger 1 minus 1 a dagger a 1 plus 1 a dagger square 1. Is it getting heavy or is it normal? How do you feel, guys? I think it is normal if you can understand it. Karthik, Murli, Hari, is it going in the right way or is it going over your head? Tell me. Normal? Okay. If you are not able to understand any point, you can let me know. Simple. You just need to follow these properties. You see. What about this value? A square applying on 1. So 1 time making it 0 again. So this is 0. A dagger applying on 1 making it 2. Then A will come back to 1. So how much is this? Here root 2 into root 2. So this is root 2 square. So this value is 2. A applying 1 making it 0. A dagger square. So it will again be 0. Have you made any mistake? Yes. This is not 0. This is 1 actually. A applying on 1 produces 0, then A dagger making it 1 again. So this is 1. Minus m h cut omega by 2 multiplied by, here you can get minus 2 and minus 1. So it is square root of 3 times square root of m h cut omega by 2. Square root of m h cut omega by 2 is p naught, so it is square root of 3 p naught. So it is matching with option B. Very fantastic problem. Look, I will recommend you to revise these problems. You will enjoy also and you will be able to do it in the real exam also. Murli, Understood? Harry, Karthik, is this problem understood? Let's do another problem, one last problem, then we will wrap up the session. I think you will now be able to solve any question from harmonic oscillator. A free particle of mass m moves in one dimension. At t equals to 0, the normalized wave function of the particle is psi is equals to this. The value of the momentum spread is. Look, here it is not explicitly mentioned that it is under the harmonic oscillator potential, but from the wave function you can see it is harmonic oscillator. There are two approaches to solve this problem. Gaussian function, yeah, in harmonic oscillator also you have seen this Gaussian function, right? If you look at the ground state, so it has similarity with the ground state wave function. There are two approaches to solve this problem. One is the rigorous process. Rigorous process means you find out the expectation value of p square. Expectation value of p is 0, that you know what is the expectation value of p square in this state. So let's do the rigorous, then I will tell you the shortcut way. Okay. So you need to find out this sigma p is equals to p square average minus p average square. So this p expectation value of p, it will be 0, right? Now p square, expectation value of p square is equals to minus infinity plus infinity psi star. P square is minus h cut square d square by dx square. It's a one dimension, so we can write d instead of del. You can write it in this way. So this is equals to minus h cut square minus infinity plus infinity. Look, double derivative of psi. Psi is given by this expression. So psi star into psi. So real function. So it is like the constant part will be multiplied. 2 pi sigma x square to the power minus 1 by 4, the square of it. So minus 1 by 2. So it becomes 1 upon 2 pi sigma x square to the power half. Right? Now into derivative of psi, derivative of this thing, exponential minus x square by 4 sigma square. So minus 1 by 2 sigma x square plus x square by 4 sigma x to the power 4 exponential minus x square by 2 sigma x square dx. Can I write it? You see, exponential term is appearing twice, one from the derivative after the derivative, and one from psi star. So that is why instead of 4 sigma x square it becomes 2 sigma x square. I hope this is clear. And these two terms are coming because we have taken double derivative, and you will get it. So this is equals to minus h cut square by 2 pi sigma x square to the power half. I am just showing you the rigorous method. I will show you the shortcut method very soon after this. Minus infinity plus infinity, you see we will get two terms. So minus 1 upon 2 sigma x square e to the power minus x square by 2 sigma x square dx. This is the first term. Second term, minus infinity plus infinity 1 upon 4 sigma x to the power 4. Okay, x square e to the power minus x square by 2 sigma x square dx. Now you know the formula of these two things, minus h cut square by 2 pi sigma h square to the power half. The first integration, minus 1 by 2 sigma x square, this is constant, e to the power minus ax square dx, this is in the form, you know it, minus infinity plus infinity, e to the power minus ax square dx is square root of pi by a, square root of pi by a. A is what? Whatever terms you have, 1 by 2 sigma x square, this is a, so 1 by 2 sigma x square, this is a, plus 1 upon 4 sigma x to the power 4. This is integration of x square e to the minus ax square dx. So you know the formula. So square root of pi by 2 to the power n plus 1. Here n is equals to 2. Okay. So we can write it 1 by 2 sigma x square uh, 2 to the power n, a to the power n plus 1. So this becomes 2 to the power pi by 2 to the power n, a to the power n plus 1. So it will be cube, 2 cube sigma x over 6. Do you remember this formula? We have done it in mathematical physics class. If you remember, we have used these two formula, minus infinity plus infinity e to the power minus ax square dx, square root of pi by a, minus infinity plus infinity x to the power n to the power minus ax square dx. It is equals to 0 if n is odd. It is equals to 1 into 2, 1 into 3 into 5 into dot dot up to n minus 1 square root of pi by 2 to the power n, a to the power n plus 1. This is the case when n is greater or equals to 2 and even. Have I written the right formula or any mistake we have made? Just check this formula. Okay, I think this is the right formula. So for the second term, a is equals to 1 by 2 sigma x square. So pi by 2 to the power n, n is equals to 2. So that is why we have written as a 2 to the power 2. And 1 by 2 sigma square, so this is coming to the numerator, n plus 1. So n plus 1 is 3. So 2 to the power 3 sigma x square of that, so it becomes 6. Is it clear or not? Tell me, guys. This is equals to minus h cut square by 2 pi sigma x square to the power half. If you just simplify it a little bit, minus 1 by 2 sigma x square, say square root of 2 pi sigma x plus 1 by 4 sigma x to the power 4. This becomes square root of 2 square root of 2 pi by square root of 2 pi only, and sigma x cube will come, so this 4 will be vanished. And if you calculate this, root 2 pi by, here also 2 sigma x and root 2 by 4 sigma x. So minus 1 by 4 sigma x root to root 2 pi. And here also you can see, so it becomes plus h cut square by 4 sigma x square. So if it is so, therefore spread sigma p square average P average square. P average square is equals to 0. So it's to P square average h cut square by 4 sigma x square. So this is h cut by 2 sigma x. That is matching with option D. Okay, so we have done. Look, this is also a good approach, but let me tell you a very short trick or based on the knowledge you have. Okay, so this is the alternative way, alternative solution. Alternative solution, this is a creative solution you can use. If you are smart enough, you can do. So what is given? Given psi is equals to, if you look at it, it is 2 pi sigma x square to the power minus 1 by 4. Okay. So we can write 1 upon square root of 2 pi sigma x. I am writing this. Okay. Okay, let's write first whatever is given. One upon 2 pi sigma x square to the power minus 1 by 4 exponential minus x square by 4 sigma x square. This is given to you. So I am just writing it 1 upon square root of 2 pi. So when I am writing 1 upon this, it means this minus sign is not there. So it is like 1 by 2 we have taken. So that makes this and remains 1 by 2. Okay, now exponential minus x square by 4 sigma x square. Now we know the ground state of 1D harmonic oscillator, psi 0 of x. Alpha by square root of pi to the power half e to the power minus alpha square x square by 2. We know it. Okay, na? This is the ground state wave function of a 1D harmonic oscillator. And for this one-dimensional harmonic oscillator, what we know? Look, in general, for nth state, we have calculated the spread in momentum. If you remember, we calculated n plus half times m h cut omega j square root. Do you remember this result for nth state? So for n equals to 0, ground state, sigma p is equals to square root of m h cut omega by 2, right? So for n is equals to 0, we get this one, and this wave function and this wave function is looking similar. So obviously the spread will be same for both of them. Only here things are given. Here it is given in terms of alpha, here it is given in terms of sigma. So if I express this sigma p, which is given as m h cut omega by 2 square root, in terms of the given parameters of the given wave function, then we will get our answer. Actually this we have to find out, but in terms of the parameters of this new wave function. You see, alpha we have already know for alpha what is the value of alpha. It is square root of m omega by h cut, है ना. Alpha is equals to m omega by h cut. Now from this what we can say, you see, comparing psi and psi naught, we get, you see, 1 by square root of 2 pi sigma x. So what we can write, alpha square by 2 is equals to 1 by 4 sigma x square. We can write. Can I write it? Okay, exponential part you compare. Alpha square by 2 is equals to 1 by 4 sigma x square. Right? So from here you can get the value of alpha is equals to 1 upon root 2 sigma x. Therefore spread we know that is m h cut omega by 2. This is what you have to find out. Now alpha is equals to m omega by h cut, m omega by h cut. So square root of m omega is equals to alpha root h cut, isn't it? Alpha root h cut, and h cut was already there, so h cut square divided by root 2. So alpha h cut by root 2. Alpha is equals to 1 upon root 2 sigma x, and h cut is h cut. So h cut by 2 sigma x d. Getting? So you can see alternative solution is quite easy. You just need to compare the psi and psi naught. From the psi and psi naught, alpha and sigma x, we found a correlation between alpha and sigma x, and you know the spread we have already. If you remember this result, then only it is suitable. If you remember this result of sigma p m h cut omega by 2 square root, then you can easily find out in 1 or 2 steps. Is it clear or not? Tell me. So while doing a lot of practice, you develop this kind of problem solving trick, and that becomes helpful in your actual exam. If you do it rigorously, you will get the answer eventually, but there is a high mistake that you will make mistake. There is a high chance that you will make mistake while doing these calculations. Okay, but while doing this calculation, there will be less chance of making mistake. You can see the calculations are relatively easy and straightforward. So if you know the things pretty well, you can play with the solution. You can just look at the problem from different angles, and you can find the answer in a very shortcut. Okay. Any question from this? If you have anything you could not understand, you can let me know. Otherwise, we can end the session here. From the next day, we will start angular momentum. Bye bye. Take care and revise. Okay, please do revise these questions. Otherwise, you will forget. You will not be able to solve it in the real exam if you don't practice and revise. Revision is the key. Okay. Bye bye. Take care.